What's that?
Real bad.
Depends.
Because I did that and it worked.
Square root tangent? It's not squared though.
I probably did it wrong.
Alright. There's a couple of ways that you can do this one. First way to do this one is the algebraic way. Now, cotangent is the inverse of tangent. Does everybody agree? So if I rewrote this, I can say it's tangent theta equals 1 over tangent theta. You okay with that? Oh, sorry. I was getting ahead of myself. Which means, yeah, it is. I didn't tell you that one, Brent. I'm sorry, man. There's this new property. We just made it up. It sounds great. Now, how do I undo divided by a tangent? I multiply by a tangent. And this is where you're at. Now I know what you did. Because that's the long form of the algebra. So by doing this, I'm going to get tangent squared theta equals 1. Which means, what angle, bless you, what angle has a tangent value of plus or minus 1?
That's it.
That's it. So where is tangent plus or minus 1?
Pi over.
At all your 45s. Okay? Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. That's the pure algebraic way to do it. Isn't there an easier way? If you think about it, reciprocal properties. We know that tangent of 45 is 1. What's the reciprocal of 1? 1. So that means at 45, tangent and cotangent will always be equal. We know that the tangent at 3 pi over 4 is negative 1, which means the reciprocal of negative 1 is also negative 1. So could you have just seen that and know, hey, in only places that tangent and cotangent are the same will have to be on the 45s? And not have to have done the algebra? Absolutely. You could have done that. But if you did the algebra, there's nothing wrong with that, because now it has been proven what is and what shall never be.
What if it's sine squared equals 1? Is sine equal?
Yeah. Quadrantals. Where's your y value equal to 1? Now you said sine squared, didn't you?
Oh, yeah. Just
So
sine.
where is it plus or minus 1? Where's your y value plus or minus 1?
At the
Exactly. Pi over 2, 3 pi over 2. Okay? Which one? Sure. We okay on this one? Does that help? Not as crazy, scary bad as you think, is it?
Maybe a little bit.
You? Never. There we go. What do you think I'm going to change cosecant to? 1 over sine. So can I just multiply both sides by sine? Is that okay? If I multiply both sides by sine theta, I will get 2 sine squared and a sine. I can't see. You okay with that? Subtract the 1. What times what is it? Negative 2? You add together to get positive 1. To a negative 1. So we get 2 sine squared minus 1 sine squared. Not sine squared, excuse me, 1 sine plus 2 sine minus 1. What I'm doing here is I'm setting us up to be able to factor by grouping. Oh, Trek, did you get a copy of this one? Or would you print it online or anything? I got a paper copy back there if you want one. What's the GCF of the first two? Sine. GCF of the second. That's fine, very good. Are the two things in parentheses the same? Again, that's a good sign. Every time I say two sine, I want to say two sine. That's all. What angle has a sine value of -1? 3 pi over 2. And what angle has a sine that is 1/2? That means you're looking at the one, you choose your hypotenuse, which means you are a pi over 6. Sine is positive, first quadrant. Use the reference angle to come around to what other side? Second quadrant, you are at? Yep. Oh, reference angles, you're so much fun. Would you like Das Boot to step on your foot and then your foot over it and you will forget about your head? My tennis. It's not to be confused with meiosis. Awkward glare. Yes, I get it. What else you want to do? We're okay.
Can you do 14? Thank you.
Welcome.
I don't have a dollar.
Thanks.
For you.
Oh, you're gonna kick yourself.
I mean, can
What's
you?
what's tangent times cotangent?
Oh man.
Why
Why are you hitting my head?
I was like, sine over cosine.
Yep.
Sine over
Yep.
cosine.
2 sine squared minus 1 is 0. What angle has a sine of plus or minus 1 over root 2? So that'll be at your 45s.
Are you serious? Hey, you know, sometimes. So math smart?
Did you really try to go through and write it as like cosine squared?
That's what I tried to do,
Oh,
but then I
sine
erased
squared
all of it.
Minus sine over cosine times 1 over sine over cosine.
Don't overlook the obvious. Don't overlook the obvious.
And then I made it all
It's so
cosine.
much easier to just overlook the obvious.
That's true, yes. If it's obvious, it's very easily overlooked. It's tricky to rock a rhyme, but it's. Sorry. Look at the bad glare from your face. You know it's right on time. Peter Piper was out on the way in. That's a great song. So old school. What?
You remember Cody that he's just sit there. Driver's ed.
Peter Piper? Run DMC.
The weird glass.
That's great. You don't remember? You don't know it?
She had the guy would talk.
Seriously.
Children. Like, would be the worst train.
All right, 45.
Sorry.
I'm going to work on number 45, but I also want to write it in terms of what we're going to call a general solution. So this is a couple of things we're going to do here, and then show how it works with the property. Excuse me. How we still write up our solutions. But then I want to remind you guys how we talk about it in terms of generality. Okay? So we have sine to the fourth x minus 1 equals 0. I need to figure out what in the world to do with that. So I can FOIL it. Well, I can't FOIL it. I can factor it. Is this a perfect square? Yeah. Is this a perfect square?
Sure.
Is this a subtraction symbol?
No.
Yes. If you have answered yes to all three of these questions, then I have something to sell to you. It's called a difference of squares. It's okay. You don't have to pay now. You can pay later. With our easy installment plans of sine squared x minus 1 and sine squared x plus 1 equaling 0. Good. Which means you just don't have any fun with this. Poopy pants. Which means one of them is going to give me an answer. The other one's just going to look at me crazily, more so than you guys are right now. Because you're imagining that I'm an idiot. But in your mind, I might literally be an idiot. So, you see what I'm doing here? Imagine what I'm getting at. Method, there's method in my madness, believe it or not. Which of these two terms you can just think about, but you can't talk about?
Do you think he goes home and like?
No, my wife would yell at me.
Do you like go home and like practice this in the mirror? Like, what am I gonna say to these kids tomorrow?
I wing it. Are you kidding me? I'm not that witty. I roll with it. I know what I want to talk about mathematically.
Practice her. Yeah.
My kids don't laugh at me. They're
I mean, we don't really laugh here. I mean, sometimes I do.
Honey, you're a bully.
How am I bullying?
So,
Did you hear me?
no, I didn't hear you, but I just should feel ashamed.
myself.
All right, so this one here is asking me what
If you're the
angle
-1.
has a sine value of plus or minus 1. Because I take the square root of 1, I get plus or minus 1. Now, if sine's going to be plus or minus 1, that means I'm going to be on my quadrantals. All right? Well, sine is your y value. Where is your y value plus or minus 1? Pi over 2 and 3 pi over 2. So those would be my list all within a revolution. But yet I'm going to ask us to write this in terms of a general solution. So how would I write this out in as generally as possible? Very good. Which means that my answer would be pi over 2 plus pi n. Which means the number of times, no matter how many times I rotate through, every one rotation gets me to a solution. And that's what general solutions mean, to get you through it. And go from there. Now, the other solution was imaginary. Did I tell you guys that you will have imaginary complex numbers and trig values next year?
We're not there.
Yeah, that's next year.
I know.
Yeah, we're not there.
It's a good thing we're just doing that now.
Just
I
think
keep
about it.
forgetting that
Now
you're
don't
like so
make
far
us.
away, so I live
Already have
right
it. That's right.
be right there, and you're
I
like,
can destroy it.
You will. You have trig of the complex value. Okay.
oh, it's funny.
All right, let's
What
do
is
another
up
one.
with your attitude today?
I'm just sitting with Brayden.
I'm working on the if I just told yeah, it's all the stuff right there.
Let's try to do
Let's do 38.
Hey, you can't do that. Now you have to say it.
Nope. I can't be negative, remember?
Just this one time.
Excuse me.
Imagine
I feel bad for any of you guys that are also suffering from allergies. I just, it's not fun.
I'm not.
Well, I don't feel sorry for you.
That's good.
I just feel sorry for you for other reasons.
And you call me negative.
Jeez.
So in this one, you're going to have cosine times tangent minus 2 cosine squared equals negative 1.
Thank you.
Now, in this case, we have to figure out a way to put everything in terms of one of the trig functions. Well, I see that cosine tangent. In my mind, I'm thinking, hey, tangent can be rewritten as sine over cosine, can't it? So what's cosine times tangent going to have to equal? Sine. This here is cosine times sine over cosine, which gives me that. So if I do that, that gives me my idea of what do I have to do with the cosine squared thing? What do I rewrite cosine squared as? Yeah. So by taking this and simplifying that first, because in your head you see this cosine squared. Well, you know tangent sine over cosine. Please not, just humor me. Thank you. So as you know that tangent is sine over cosine, if you multiply cosine times sine over cosine, the cosines simplify out and you result with sine. It's kind of like 2 times 3/2. The 2's drop and you get a 3. Same basic principle. You're simplifying out a vector of 1. So now you have sine of x minus 2 cosine squared x equals negative 1. Now, this goes back to a trick that we did a few weeks ago. When you have a Pythagorean identity, or when you have a squared trigonometric identity, you always want to try to rewrite the squared term as the non-squared term. So just like earlier, when you see a cosine squared, that means you can rewrite that using sine squared plus cosine squared is 1. Cosine squared is 1 minus sine squared. So we have sine and ladies and gentlemen, I can tell you right now where you're going to make a silly mistake. And you probably know what it is too. What are you going to forget to do? Just distribute the negative to the secondary term. It happens all the time. Okay. So when you simplify this out, you get sine of x minus 2 plus 2 sine squared x, and then equals negative 1. See what I mean? That's such a common mistake. And then when you do that, if you go through it, then you'll wind up with an opposite term in the middle. Your work would all be right. You might have a different, your angles would probably just be in the wrong quadrants. And it's just so easy to make a simple mistake. Now what am I going to do? What do you think we should do? Very good. So do I have a positive sine squared right now, or do I have a negative sine squared? So should I move them? No. Let's just put it in descending order. Okay? Add 1, and we just did this terms of this one a minute ago, didn't we? I think we did. Did we just do a 2 sine squared? I thought we just did this problem.
I have no idea.
Yeah, we did.
Yes.
Okay, so are we okay if I stop here because we just did this problem? Or was this a general solution? Did we do a general solution like that, or was it regular? It was regular. All right. What was the answers? We'll just write that real quick. What were the answers to this? Anyway, so
Sine plus 1 to sine minus 1.
so a sine plus 1 and 2 sine minus 1?
Yes.
Thank you. So as we go through this in terms of general solutions, this is saying what angle has a sine value of -1? Well, we wrote that earlier. It was 3 pi over 2. That's the only place that that occurs. So how do you write that in generality? Is it pi n or 2 pi n? It's 2 pi n. Because to get back to -1, you have to go all the way around. And then here is what angle has a sine. And we did that as pi over 6 and 5 pi over 6, I believe. Now, visually, pi over 6 and 5 pi over 6, to get from 1/6 to 5/6 is not the same as 5/6 to come back around. So they don't have a standard distance between the 2 points. So since that occurs, I have to write plus 2 pi n for both solutions. Okay? And that's how I would write this in terms of a general solution. Okay? That's what that would look like. Okay. You all right? At least it's not going like your nose. Thank you. Sorry, I was going with that. What was the other one I wanted to look at? If I look at 39, I have 3 tangent squared x equals root 3 tangent x. What do you think you want to do first? It's not allowed. Well, it is allowed, so there's that. What should we do first?
Square root, square root.
No, can't divide. If you divide by tangent, you eliminate a possible solution. So think about this in terms of having to factor a lot. To find zeros, what do you always have to have? A 0 somewhere. Which means we should probably set one side equal to 0. So which side should we move, left or right? Let's move the right side. So if we move the right side over, what's your first rule of factoring? Take out the GCF. Good. So if I take out my GCF, I have tangent of x times the quantity 3 tangent x minus root 3 is 0. Do I now have 2 terms that I can set equal to 0? Yeah. So now I have 2 terms that I can set equal to 0. So I have tangent of x is 0, and 3 tangent x minus root 3 is 0. Tangent is what over what? Tangent's sine over cosine. So this is asking me what angle has a tangent value of 0, which means where is y over x, where is y 0 and x 1, or plus or minus 1. It'd be 0 and pi, right? when you're dealing with zeros with tangent, a big suggestion is to always remember that it is sine over cosine, and then just rewrite it as y over x. Because we know that the sine values go with y. The cosine values correspond to x in the ordered pairs as far as the unit circle is concerned. But here we're not worrying about all the ordered pairs, we're just worrying about the quadrantals. Because that's the only place that we can get zeros. So it's just a little trick to help remember how these things set up. So general solution would be at 0 and pi. So my answer would be 0 plus pi n. Are we okay with that? The other side, on the other hand, is going to be what angle has a tangent value of root 3 over 3. Which one is it? The 30. Because the 30 is adjacent, excuse me, is it the 30 or the 60? Because remember, it's your opposite over the adjacent. Oops. Yeah. So it's a 1 root 3. Sorry. You I wasn't. I was being rational. I wasn't getting real. I was being irrational. I have no idea what I'm saying. I'm trying to cover up my tracks of making that. Yes. You don't get this kind of entertainment throughout the rest of your days, do you?
Sometimes.
No.
I understand.
You don't like it.
I like
Gundy's cool. Gundy's very cool. So yeah, Trap, you're right. So this is at pi over 6. Where else is tangent positive? Third quadrant. Now, what's nice about tangent values is that this is your reference angle coming down, so that's also going to be at 7 pi over 6. Aren't these two values equidistant from one another?
Yes.
Yeah, so what do I write for my n value? Pi over 6 plus pi n. What's that? Now, could you imagine if we did all of this earlier with all the identities all at once, instead of just a little bit of equations,
It's the last one we're doing.
and then throwing all the identities all at the same time? It was a lot. And I did, like I said, I tried something a little bit different this year by putting the identities at the back end. And I think it's kind of not that bad. That way it wasn't super overwhelming up front. Okay. What I'd like you guys to try and work through on here is, I'm pretty sure you can, I'm not going to, we can skip that one and this one. This is the same thing here. I'm not going to worry about this. Those are getting a little goofy. What I would try, let's see, what we haven't done. We haven't done, I try to get those. Those are pretty quick. See if you can get 41 also. That one's nice. All right, try and get those through, okay? Because you're saying about 48? What would you do with 48?
I don't know, I just want to really do 48. I haven't actually looked at the problem.
Oh, see how you have sine and a cosecant?
Yes.
Rewrite cosecant as 1 over sine and get common denominator for everything.
Yay.
And it works out real quick. All right? You'd be surprised at how fast that actually goes through once you do that. Okay? All right? Try those 6 and let's see how we do. All right? I'll put together a couple more identity stuff tomorrow. We'll put it all together and see what happens.
No, you don't get to call me a bully in this paper.
Oh, I gotta change that. Hey, Knucklehead, Sawyer, will you erase the last week's stuff for me right there?
I swear, everybody calls you a knucklehead.
It's easier. He responds. Most people respond when you say, hey, Knucklehead.
Knucklehead chemistry.
I feel like I don't respond.
Were you talking to me?
He thinks